So in this lecture we are going to discuss the interference due to thin film, right? Interference due to thin film. Thin film. What is the thin film, Newton? Thin film like the disc. If you have seen the compact disc CD, right? When you will see the disc, it will seem colorful, right? Also, if sometime the oil layer, right, is spread over the water, and when you will see the oil layer, it seems to be colorful, and this is due to the interference due to the thin film. Alright, so we are going to discuss that thing, same thing. Suppose this is a thin film. Thin film means you may consider this is the film made of glass or some substance, transparent substance, or it may be the liquid. The refractive index I can suppose mu. Alright, suppose the light is incident over here. This is the first I will consider for the normal incidence. Normal incidence means normal incidence. Normal incidence means the light is coming normally, right? The thin film is of thickness T. Is it clear or not? Right. If the thin film thickness is T and the light is, this is the incident light. So when the light is incident, some of the part will be refracted and some of the incident light is reflected from this. Now this is the refractive light. Again there is a reflection from this and the refraction from this, and when you see these two waves, one wave and the two waves, right, you may get different color, the different color, right? So again this light is incident, it is reflected from here, it is reflected from here, and it is refracted over there. So these type of the wave when you will see from this side, so these are the lights which are coming and which are producing the interference. This system of the light rays are called the reflected system, right? This is the reflected rays or reflected system of rays. Is it clear or not? Listen, here also the some light ray will transmitted like this. It will be reflected, partially reflected, then it is transmitted. Then you see the wave from this side. Alright. So this system of ray is called refracted or transmitted system. Transmitted system. Right? Copy this. Listen one thing. So if you consider the reflected system, right? So this light is transmitted. If you consider the path difference between the first and the second wave, right? What is the path difference of the first and the second wave? Listen one thing. It is the rarer medium. Suppose this is the air, and this is the liquid. This is the denser medium. So when the rarer medium, when the light is reflected, this is the normal incident, although it is perpendicularly, but for understanding we are making at some angle. So when it is reflected from rarer medium to, right, this is the denser medium. So the path difference is pi by 2 over here. Are you getting or not? This is the phase difference. The path difference is lambda by 2. Phase difference pi by 2 is introduced in the first wave. Extra phase difference due to the reflection from rare to the denser medium, right? And this one wave is moving, it traveling with distance t, then again t. Now it is reflection at the boundary, it is denser medium and it is rarer medium. So when the reflection is from rarer boundary, so no phase difference is introduced, and now this is the second wave. Alright, if you consider the difference, path difference in transmitted system, delta x is what? So if it is t plus t, so this light ray, and from here they travel with the same distance. So this is the t and t. The refractive index of this medium is mu. So the extra path traveled by the second wave is mu t plus mu t, because it is in a refractive index medium of mu. So 2 mu t is the extra path covered by the second wave, but this is the first wave, this is the path difference, this is the phase difference, and this is the lambda by 2. The path difference lambda by 2 is introduced due to the reflection, and the phase difference, corresponding phase difference will be pi by 2. So it is lambda by 2. So this is lambda by 2 is the path difference. Are you getting or not? This is the lambda. This lambda by 2 path difference is introduced due to the reflection. Are you getting or not? This is the geometrical path difference. This is the optical path difference due to the reflection. Listen one more thing. For delta phi is equal to 2 pi by lambda into delta x, right? So extra path difference is lambda by 2, right? This is lambda by 2. So this is pi. So phase difference here, extra phase difference is introduced pi. So in the reflected system, I am considering first. For reflected system, what is the path difference? Path difference is nothing but 2 mu t minus lambda by 2. This is the path difference. Now, if these two waves are traveling in the medium for constructive interference, what should be the condition? This path difference must be equal to n lambda, and 2 mu t must be equal to n lambda plus lambda by 2. It is equal to 2n plus 1 lambda by 2n plus 1 into lambda by 2. This 2 mu t. So this is the condition for the constructive interference in the transmitted system. I am explaining this, right? And for destructive interference, what is the condition? This path difference, what is the path difference between the first and the second wave? Must be equal to 2n minus 1 into lambda by 2. So 2 mu t minus lambda by 2 is equal to n lambda minus lambda by 2. It will cancel out. So this is the condition of the destructive interference in the reflected system. Are you getting or not? Copy this. Why this is the lambda by 2? So I am telling you, if this is the denser medium, right? When the light ray comes, right, and this is the boundary, rare and denser, when it is reflected from the denser medium, so an extra path due to reflection, extra path difference lambda by 2 is introduced due to the reflection from the denser boundary. Are you getting or not? If you remember the wave, right? If it is fixed, the wave is coming like this, the wave is coming like this, right? So if it is fixed, so there is a path difference of pi, phase difference of pi. It is reflected like this. Are you getting or not? Right? It is inverted, and the phase difference is pi is introduced. But if it is an open boundary and the wave is coming like this, if the wave is coming like this, and if it is open, it is fixed, so it is reflected in this way, and the path difference is lambda by 2, and the phase difference is pi is introduced. But if it is open like this, what you have to do? It is open, it will move as it is. In the same way, if we consider the light as a wave, if the light is incident to the denser medium, are you getting? So the reflected wave has the extra path difference lambda by 2. Right? But if it is rarer medium as compared to this, in the reflected light ray, no path difference. Is it clear or not? Right? So that is why if this is a light ray, some partially reflected, so lambda by 2 path is extra, covered by this light ray, due to the reflection from the denser boundary. And this is the extra path T, this is the extra path T, so T plus T QT, but it is in the refractive index mu, so 2 mu T is the extra path covered by this, but here is also the reflection taking place, but the boundary is rarer, so no extra path like lambda by 2, here it is introduced, no extra path is introduced at this point. Now this is the total path difference, you should have idea. Is it clear or not? Right. So can I copy this? Now for the transmitted system, this is the transmitted system. I am writing here for transmitted system. Right. For transmitted system, suppose the light comes like this, it moves, it is reflected, some refracted, then reflected, then it comes. So this is transmitted system of light. Are you getting or not? So listen one thing. At this till this point, the one ray and the second ray comes with the same distance. Now this is the T plus T. Here also the reflection from the rarer medium. So no extra path is introduced. So this is T and T. So what is the extra path traveled by the 2? Is 2 mu T. And after that, what is the path difference? Path difference, you are looking from this, from the other side of the medium, right? This is the path difference. What is the path difference, you will say? It is equal to 2 mu T minus 0. So for constructive interference, the path difference 2 mu T must be equal to n lambda. Is it clear or not? For transmitted system, we are talking. For destructive interference, the path difference, that is the 2 mu T, must be equal to what? 2n plus 1 into lambda. Is it clear or not? Listen one thing. When the light is incident over here, right, some wavelength which are constructive interference produce constructive interference this side, right, some wavelength are present. Which wavelength are present? So in the reflected system, these wavelength are present. Are you getting or not? So if these wavelength are present in the reflected system, they are absent in the transmitted system. So they will produce the destructive interference. Therefore, the same wavelength are absent in the transmitted system. In the same way, what the wavelength is present in the transmitted system, so these are the wavelengths which are present, right? And these are the absent on the reflected system. So when this is suppose this is the white light. White light means the VIV is the wavelength. So some wavelength will be present over here due to the interference, and some wavelength will be present over there. Are you getting or not? Which wavelength is present? Suppose yellow is present over here. Why yellow is present? Because the yellow is producing the constructive interference in the reflected system. When you are looking from this, the yellow light you will see. When you will see this thin film, and yellow light will absent in the transmitted system, and vice versa. Do you understand this thing or not? Copy this. So I am giving an illustration on this, right? For example, white light means the light of sun and all the wavelengths are present. White light is incident on glass slab of thickness T is equal to 0.5 into 10 to the power minus 6 meter, right? Refractive index is 1.5, right? So the wavelength, which wavelength are present in reflected system, constructively, right? It means we are asking which wavelength producing the constructive interference in the reflected system. So if this is the thickness T and you are looking from this, the white light is incident. So one light will be reflected from this surface, the another light will reflect from this surface. So this is the 1 and 2. So what is the path difference then? Path difference lambda by 2 is due to the reflection and due to the path difference mu t. So 2 mu 2 minus lambda by 2 is the path difference. It must be equal to say 2 lambda. So 2 mu 2 is equal to 2n plus 1 into lambda by 2. I will do that again. So what they are asking? The wavelength. So lambda is equal to what? 4 mu t upon 2n plus 1. 4 into mu. What is the mu? This is 1.5. The thickness is 0.5 into 10 to the power minus 6 divided by 2n plus 4. So this is 6.5, 3 into 10 to the power minus 6 upon 2n plus 4. Is it clear or not? If you consider the white light means the waveguide. What is the wavelength? From 400 nanometer to 700 nanometer is the wavelength. So I will write 3000 into 10 to the power minus 9 upon 2n plus 1. Are you getting or not? So this wavelength is 3000 upon 2n plus 1 nanometer. Right. First copy this. So now which wavelength are present strongly in the reflected system? You will put n is equal to 1. If n is equal to 1, so this is what? 1000 nanometer. It is out of this range. If n is equal to 2, you will put, so lambda is equal to what? 5. Because 2 to the 4 plus 1, 600 nanometer. Yes, this is in the range. This is present. N is equal to 3. Lambda is equal to what? 7. So this is 7 चौक 28, 7 दूनी 14, 7 approximately. If you put n is equal to 4, so this is 3000 upon 9, 1000 upon 3, 33.34 nanometer. So this is also out of this. So only the two wavelengths are strongly present on the reflected system. So only two wavelengths. Which are the wavelengths? This is the lambda 1, this is the lambda 2 and the lambda 3. Lambda 2 is equal to 600 nanometer and lambda 3 is equal to 428 nanometer. Is it clear or not? So this is approximately the violet color. Violet color you will see, and this 600 is approximately orange color. Orange color. Are you getting or not? So if this is the thin film means if it is a disc and you are looking from the normally from this side, the reflected system. So these two color you will observe, although the white light is coming from, white light is incident on this system, on the reflecting surface. Is it clear or not? Copy this. Listen, one more thing. This is the normal incidence, right? Okay, so this was the theory for the normal incidence. Normal incidence means the light is incident perpendicularly to the surface. Now for oblique incidence, for the oblique incidence, suppose this is the glass slab and the light is coming at some angle I, then it is reflected by angle R, alright, then it is again refracted by angle R. So it is refracted over here, then it become again I. So this is the one and in the same way, if it is R, it is R, so it will be reflected. It will be reflected like this. So this is the 3 or 4. So again, this is the reflected system. reflected system of light. This is transmitted system, right? And this is the incident light. Incident light. Now, although the path difference lambda by 2 is introduced in this way for reflected system, right? What is the path difference? Listen. Initially, before this, the light traveled the distance t, and this again the distance t. So the distance was 2 mu t. But here, if it is incident at some angle I, so this is angle r. So this distance comes to be what? Say it is r cos theta, right? So this distance cos r, if this is t, what is the cos r then? Cos r is equal to base upon hypotenuse, right? Or listen one thing. This distance when we will calculate, this is r. So this distance is r cos theta, right? So the path difference will be q mu 2 cos r. Are you getting or not? Q mu 2 cos r minus this is mu t plus mu t, but here you have to multiply by cos r because some other factor will be there, so you have to remember this. Although there is a derivation, I am not going to do that. So this is 2 mu t cos r is the path, extra path traveled by this second wave. How much it is? Q mu t cos r, where r is the angle of refraction. Angle of refraction. So 2 mu t cos r minus lambda by 2 is the path difference, right? This is the path difference. So this path difference you have to remember for the oblique incidence of the light. Copy this. For the reflected system, for constructive interference, what should be the condition? Can you tell? 2 mu t cos r, this path difference must be equal to 2n minus 1, n lambda. It must be n lambda, right? So 2 mu t cos r must be equal to 2n plus 1 into lambda. This is the one condition for constructive. For destructive interference, I am writing this side. For destructive interference, mean which wavelength are not present. So those wavelength are not present which satisfy is equal to 2n minus 1 into lambda. That is, if they satisfy 2 mu t cos r is equal to n lambda, right? This is the destructive interference for reflected system. While for the transmitted system, this is for reflected system. For transmitted system, right? The light ray comes. This comes at the same point, then it again moves this distance and this distance, and there is no extra path due to the reflection because it is the rarer medium. So the fourth light ray travels the extra path, and it is equal to mu t into cos r minus, right? It produces nothing, right? It is the same 0. This is the path difference. It is equal to 2 mu t into cos r. For constructive interference, 2 mu t cos r must be equal to what? Say n lambda. So which wavelength are absent in the reflected system? They are present in the transmitted system. And for destructive interference, 2 mu t, this is the path difference, is equal to 2n minus 1, 2n plus 1 into lambda. So these are the absent wavelength are present in the reflective system. Copy this. All right, can you open the sheet? These are the examples, right? Example number 12 it is. 12 and 13 in my book. Is this topic included in your complete? It is included in your coaching or not? Can you take the photograph? Okay, example number 12 it is. Okay. Okay. So in this question, example number 12, it is here. The light wave wavelength is 600 angstrom. All right. And this is the thin glass slab is over there. The refractive index is 1.5. Angle of refraction. So they will give the R sometime. Right. So R is what? 60 degrees given. Calculate the smallest thickness we have to find so that small of the plate which make it appear dark by reflection. So in the reflection they are talking about in this system, right? This wavelength is not present. So 2 mu t cos r minus lambda by 2 must be equal to 2n minus 1 into lambda by 2. So for absence, for the destructive interference in the reflected system I am talking about. Is it clear or not? You tell. So what should be the condition then? So 2 mu t cos r minus lambda by 2 and lambda minus lambda by 2. It is cancelled. So 2 mu t into cos r is equal to n lambda. Are you getting or not? So the minimum thickness we have to find. This is 2 mu cos r. Is it clear? So n, if it is minimum, then the thickness will be minimum. So you will take n is equal to 1, t is equal to lambda upon 2 mu into cos r, right? And r is cos 60 degree. So what is the thickness then? Lambda value is 6000 into 10 to the power minus 10 upon, right? 2 into mu into 1 by 2. It will cancel out, and 4000 into 10 to the power minus 10. So this is equal to 4 into 10 to the power minus 7 meter is the thickness. Do you understand or not? So minimum thickness of this glass slab of material is this much, so that this wavelength is not present in the reflected system of light. Do you understand this, Sanjay? Copy this. For this question, the example number 13, it is the wavelength is what? 6000 again, angstrom, and the angle of refraction is 60 degrees given, right? A refractive index is 1.5, and the glass thickness this time is given minus 3 millimeter. So the number of the band which is fine, we have to find, right? So again, this is the system, the reflected system we are talking about, right? Right. So we have to make the condition, calculate the order of the dark band. Dark band means this wavelength is not present in the reflected system. Is it clear or not? Angle of refraction, calculate, dark band is observed to the wavelength of the reflected system. So again, what is the condition for the destructive interference in the reflected system? It is 2 mu t cos r is equal to n lambda, right? So the n you have to find 2 mu t cos r upon lambda. Is it clear or not? So it is 2 into 1.5. Thickness is given It is in millimeter, so I will write minus 6 cos 60, right, and wavelength is 6000 into 10 to the power minus 10. When you will calculate this, you will get the third order band will be absent, or it will produce the dark band in the reflected system, right? Copy this.